Hey guys, this is Karan here. I live in Saudi Arabia studying 10th grade in Yambu International School. In this chapter, we are going to expand our study of identity that we talked about previously. Now we are going to find out the identity that we already know what we talked about. It will help us identify the other identities, and identity generally will help in manipulating trigonometric expressions and solve trigonometric equations. Well, here's what we know from the past, right? So from past we know this: the sine of negative x is equal to negative 2 over 3, and tangent of x would be equal to negative 2 radical 5 over 5. Now the first thing I would like to talk about is the negative x over here present. Now I discussed with you guys in my previous video, but I want to make sure that you still remember this. Alright? So it turns out that when you have negative x over here, it's just that on the coordinate graph, over here is the positive side, over here is the positive side, here's the negative, and here's the negative for the sine theta. Okay, so it turns out the sine of negative x, okay, would be something like this: sine of negative x is equal to negative sine of x. Okay, which basically points out as negative sine of x is equal to negative 2/3. Okay, so we can cancel the minus signs over here, so we can say the sine of x would be equal to 2/3. Okay, and we can find the cosecant, cosecant, which is inverse of sine of x. Okay, let me just go ahead and write it here. Cosecant, CSC, cosecant of x would be inverse. So if 2 over 3, then it's 3 over 2. Okay, and tangent of x would basically be negative 2 radical 5 over 5. Which basically points out as, if you go to cotangent of x, would be negative radical 5 of 5. Okay? Now tangent of x, whenever you have tangent of x, it's trying to tell you that it's a sine of x divided by cosine of x. Okay, so let's go ahead. We discovered one pattern right here. With that, whenever you have a tangent of x, it's basically trying to tell you guys that it's a sine of x divided by the cosine of x, which can lead us to saying that cosine of x would basically be sine of x divided by the tangent of x, and we can all agree on that. Okay, so what we can do now is basically flip this around, flip the tables around, and make it something that looks like this, that says cotangent of x would be equal to cosine of x divided by sine of x. Okay, which basically, if you multiply this two, that would be sine of x, the bracket, times cotangent of x would be equal to cosine of x. Okay, now let's go ahead and plug in the values over here that we now know. Okay, so after plugging in the values, it would be something like negative radical 5 over 5 times 2 over 3 is equal to cosine of x. Now if you multiply this together, the cosine of x that we can find out is negative radical 5 over 3. Whoops, negative 2 radical 5 over 3. Okay, basically this would, oops, be 2, this would cancel out with this one, and then we would have negative radical phi over 3 for the one over here. Okay, now when you flip this around, it would be the secant of x would be, if it's negative radical phi over 3, then it's negative 3 over radical phi. Okay, all you need to know is make your bases clear in trigonometric identities and make sure where you're going through. You need to know each and every law of sine theta, okay? Such as sine theta times cotangent which yields or basically is equal to cosine theta, okay? Cosine of x, okay? This section took me, when I first was learning this section, it took me 2 days to understand the whole process of trigonometric identities. It just was because that when I started first learning, I was like, okay, and then moved on. But that's the wrong thing. I didn't really understand the core concept. So what I had to do was go back through it, memorize all the trigonometric identities, and had to solve many more examples just to improve my understanding skills. Now I completely know what I'm doing here. Okay, so let's go ahead and take this problem, which basically says cotangent of x divided by cosecant of x. Now, just for the reminder here, some people might have forgotten this because it's a new concept here that we are first using this. It's that the cotangent of x would basically yield cosine of x over sine of x. Okay, now then its cosecant of x would yield 1 over sine of x. Okay, I just wanted to bring that up because you'll be using this over here. Now cotangent, which is cosine of x divided by, let's put it down here, cosine of x divided by sine of x, all divided by cosecant, which is 1 divided by sine of x. Okay, and then you divide like this. Okay, cosine of x divided by sine of x divided by 1 over sine of x. Then what happens is cosine of x divided by sine of x times sine of x over 1. This cancels out with this one, leaving you cosine of x over 1, or simply cosine of x. Okay, so you have this over here. Now before I start this problem, let me go ahead and mention to you guys that though we are learning the trigonometric equation using identities to simplify this expression, what I'm going to go through is showing you the technique here. Okay, so I'm going to show you the technique on how it's being done over here in this particular example. Cotangent of pi over 2 minus x times cosine of x. Okay, now using this, if you have something that comes along this line, you basically, what you need to do now is basically go draw a right triangle right here. Right triangle right here. Okay, make it at 30 degrees. Okay, 60 degrees. Now we know since it's 30, 60, 90, it would be radical 3 over here, 1 over here. Okay, now let's go ahead and do this problem. So as we move on to continue this problem, we can say sine of 30 degrees would yield 1 over 2. Okay, so sine of 60 degrees gives us basically 1 over 2. The hypotenuse is 2 here. Oops. We can get radical 3 and 1 over here. So it's 1 over 2. Then we can say cosine of 60, which is that would also be 1 over 2 cosine of 60. Then sine of pi over 6, which is equal to 1/2 cosine of pi over 3, which is also equal to 1/2. Okay, so we can continue this problem like saying pi over 2 minus pi over 2 minus x. It basically is pi over 2 minus pi over 2 minus x. That would basically gives off this 2. That would basically remind this of x. This, because of this minus and minus, this would become plus over here, leaving you positive x. Okay, so now what you need to do is basically you have tangent of x, cosine of x, which is basically sine of x over cosine of x, right? It basically means cosine of x, which is equal to sine of x. Because, see, cosine of x cancels out with cosine of x, leaving you sine of x. Okay? Now here's an opportunity where we need to factorize a situation in trigonometric identity, so let's go ahead and do that. And again, if some things doesn't make sense to you, you may go ahead and replay the video, because I'm sure if you do it once or twice, you understand what I'm talking about. So if you have sine squared x minus secant squared x minus sine squared x, which basically yields out sine squared x multiplied by secant squared x minus 1. Okay, and this, if you guys remember, there was an identity like this, and since I'm running out of space, I'm not going to write it, but you should remember this from our previous section, which basically yields out sine squared x divided by cosine squared x plus secant squared x would turn out to be cosine x divided by cosine squared x, okay, which equals 1 over cosine squared x, okay, which turned out that this whole thing would turn into tangent squared x would equal to 1 over cosine squared x. Okay, now this whole thing will turn out into tangent squared x is equal to secant squared x. Secant squared x. Okay, so we can also flip this around and write it as, okay, let me just go ahead and erase this space over here. You can also flip this around and write this equation as sine squared x multiplied by tangent squared x. After we move this from here, this would give us that one. And since if you want to make this the whole thing, the tangent squared x can also be written as sine squared x multiplied by sine squared x divided by cosine squared x. You see, we're continuously changing the whole equation. From secant, we went from sine to multiplied by tangent. From tangent squared x, we went from sine squared x divided by cosine squared x. Okay, so you need to continuously keep changing it if you are able to. Okay, then you can multiply each other. Sine raised to the 4th power cosine squared x. Okay, so this is your final answer, since we cannot simplify any further. Okay, So let's go ahead and talk about the last example in this whole section. Okay, so let's go ahead and do that. So if you were to given that it's a very peculiar example, in the square root you're given that it's phi tangent theta squared plus 25. Okay, what would you do? Well, it's a Pythagorean identity, as you guys can see, but the thing you need to do is that now it's like this. You can take this, square this thing, whole thing, which will make it 25 tangent square theta plus 25, right? We just simplified this. Now let's go ahead and make it into more simplified version, which is 25, and make it tangent square theta plus 1. Okay, if you multiply this, it will give you the same thing. You basically keep on going down. Now if you see this, this would turn out to be in 25 secant square theta, okay, which if you cancel this parenthesis with this and this with phi, giving you phi secant theta. Okay, and this would be your final answer. Okay, so I hope you guys enjoyed this video. It really helps me a lot. If you watch it, share this video with your friends and family. Guys, you can do me a favor that there's a URL, Facebook page URL down below in the description area. Go ahead and click like button on it. It helps me a lot. Thank you for watching. Peace out.